In this video, I'm going to talk about functional group. If this is the first time coming across our video or visiting our channel, don't forget to like, share, and subscribe. So what are functional groups? Functional groups are basically a single atom or group of atoms, right, that basically determines the function of an organic compound. From the word functional, right, you can basically understand that, okay, there's something that we call function here, right? So any group of atom or a single atom, it can be a group of atom or a single atom, right, that confer a function or that determine the function of an organic compound, right? Such atom and group of atom is referred to as functional group, right? So in that case, you basically say they are specific group of atom, right, or bond. It can be bond at the same time, right? It can be an atom or bond that are present within an organic compound, right, that determine the characteristic of that compound and at the same time the function of that compound. So that's basically what functional groups are, right? So they determine how reactive a compound is, and at the same time the chemical properties of the compound, of the organic compound, is determined by the functional group. So we have different types of functional groups, and I'm going to list them out now. So the first one that we have is actually what functional group based on bond. We have what alkene. Based on bond, we have what alkene, and also we have what alkyne. This is actually based on what? Based on bond. They are the let me say type of functional group that we have based on bond. We have the double bond and the triple bond and also what single bond. So this basically determines what the reactivity, like it determines the reactivity of what of the compound. So any compound that have just a single carbon atom, they can only undergo substitution reaction. Substitution reaction. And listen carefully. When it comes to functional group, all like, let me say any compound that belongs to alkene, they can only undergo substitution reaction. Why that of alkene and alkyne can undergo addition reaction? And that's because they have what? They have double bond and triple bond. That is, they have unused bond, right? So that's basically what we have here. Based on bond, we have what? Alkene, and also what? Alkyne. And alkene and alkyne are what? And unsaturated hydrocarbon. Why alkene is what? Is saturated hydrocarbon. Now let's go ahead and talk about other functional group that we have. We have the case of hydroxy group, right? We have the case of let me say carboxylic acid, right? Then we have the case of aldehyde. We also have the case of ketone, right? RCOR, that's ketone. Then we also have this case of ester, right? That's RCOOR, that's ester, right? So in that case, based on bond, we have alkene, and also alkyne, right? Based on the presence of oxygen, that is the presence of oxygen, we have hydroxy functional group, we have carboxylic acid functional group, we have aldehyde ketone functional group, and also we have ester functional group. They are basically classified. They are their functional groups are classified based on on oxygen, the presence of oxygen, because the presence of oxygen in this functional group also helps to determine the polarity, the solubility of this functional group, right? So in that case, we have hydroxy group. This is basically hydroxy functional group. This is basically carboxylic acid. So example of alcohol, let me say compound that has hydroxy group or alcohol, you basically say we have the case of ethanol, right? We have ethanol. We have, let me say, propanol. They are basically example of alcohol that has this functional group. Then at the same time, we have carboxylic acid. This can basically be carboxylic acid, that's functional group. Then we can have ethanoic acid is an example. Ethanoic acid. Then we can have propanoic acid, right? So under this aldehyde, this is basically aldehyde, right? This aldehyde, we can basically have ethanol, right? Ethanol, right? We can basically have propanol at the same time. Propanol, they are example of this functional group. Then this guy that you're seeing here is actually ketone, and in that case, it's also part of the carbonyl compound, but it's just that the carbon to oxygen bond is actually found in between another carbon. This is a carbon here, this is a carbon here. This is an alkyl group, and this represents an alkyl group. So in that case, this is basically ketone, right? So we can have an example. We can have ethanol, right? Is an example. Ethanol is an example of ketone functional group. It has a ketone functional group. Now another thing I want you to know is actually the case of let me simply say, I think we have ester, right? This is ester. So an example of ester, we can have ethyl ethanoate. right, ethyl ethanoate, you can basically have, let me simply say, propyl ethanoate, right? So there is basically example of what, of ester that we have, right? So this functional group, they are basically classified based on what, because based on the presence of what, of oxygen. While these ones that you're seeing here, they are classified based on what, based on the presence of what, of bond, double bond and not what, triple bond, right? They are classified based on what, on bond. While these ones are classified based on what, based on oxygen containing groups. Now the next one that we have that I'm going to talk about is actually what, the nitrogen containing groups, right? Those ones that contain what, nitrogen as the functional group, and we have them to be, let me say, we have amides, right? Amides. We have amides, right? We have amine, right? And at the same time, we have nitrides, right? So they are classified based on what? Based on nitrogen. They contain nitrogen. They are functional groups that are classified based on what? Based on nitrogen, right? So in the case of amide, I think amide is basically, let me say, we have RC double bond O, then we're going to have NH2. So this is amide. Then amine can have it with NH2. That's basically amine. And when it's come to in the case of nitride, nitride is basically kind of let me say, it contains carbon to nitrogen triple bond. That's basically nitride, right? So that's example of nitride. And example, and let me just give you example of nitride. So I think we have 18 nitride exactly. So it's an example of nitride. It's an example of nitride. Let me basically draw it out. You can have something like this. Let me just say we have what, nitrogen here. Then we have carbon here. This is going to be triple bond, right? Then we can have another carbon here. We're going to have hydrogen here, and hydrogen is here. So these two carbon atoms. So this is basically 18 nitride, right? So this is nitride. This is the nitride functional group, right? As you can see. And then everything you're seeing here, since we have carbon 1 and carbon 2 here, that's basically 18 nitride. So it's an example of what, of nitride functional group. Then when it's come to amine, right? When it's come to amine, we can have, let me simply say, we can have CH3, right? H is here, H is going to be here, H is going to be here. Then we're going to have, let me simply say, we have this guy here, which is going to be N is connected to this guy. Then we're going to have NH2, right? So this another one. Since we are going to have this basically one methyl group, right? You can basically call this one methyl amine. We're having one carbon atom here. If you look at this very well, and this is nitrogen, not carbon, unlike this nitride. So this is going to be methyl amine. Methyl amine. That's an example of what, of amine that we have. Now an example of what, of amide is when you actually have, let me say, we have R in this case, let me just call it, this is going to be H is here, H is here, H is here, right? Then we're going to have this double bond O, right? And we're going to have NH2, right? So if you have something like this, that's basically, let me say, this carbon 1 and carbon 2, and that basically represents what? Ethane, right? That's ethane. So we can call this one ethanamide, right? That's basically ethanamide. So it's an example of what, of amide functional group, right? So that's basically what happened here. So if you look at this very well, in the case of nitride, we have nitride here. In the case of amine, we have amine here. In the case of what, amide, we have what, amide here. So that basically means all these functional groups are actually used as what, as the suffix, right? And the reason they are used as what, as suffix is because they determine the chemical properties of what, of that compound. In the case of what, of ethanol, which is ketone, the ON is simply represents what, ketone. Ethanoate, this OATE is represents what, ester. So it comes as the suffix end, and that's because they are the functional group that are present what, in a compound. So whenever we are talking about functional, whenever there is presence of what, of functional group in a compound, that particular functional group will determine, will be named, will come as what, will be used as what, as the suffix, not prefix, right? So let me just basically talk about the suffix and also the prefix. But before I actually move to that, I think we have one more classification, and that's actually the case of halogen, right? Because we also have some compounds that contain halogen, and they are basically referred to as what, they can be haloalkane, they can be haloalkene, right? Depending on the bond that are present here. So let me just basically write them out as well, right? Because they are also part of the functional group that we have. So we have the case of what, of, let me say, halogen containing, right? And example, halogen containing compound. Then example, we have what, case of what, of haloalkene. Haloalkene can be chlorine, it can be bromine, it can be what, it can be fluorine. Then let me just give you an example. Let's say we have a compound here, right? And here we are having what, Cl here, hydrogen is here, hydrogen is here, hydrogen is here, right? And then hydrogen is here, hydrogen is also here. let's fill everything with hydrogen. Now if you look at this very well, chlorine is what's connected to this guy here. We're going to have 1, 2, 3. So this is basically 1 chloro, right? 1 chloro. Since it is 3 carbon atom, we call it what? Propane. 1 chloropropane. So this is an example of what? Of alloalkane. It's contained halogen, right? And then at the same time, the next one that we can have the case of what? Of alkyl halides, right? Alkyl halides. Alkyl is actually what? A substance that are connected to what? To halogens, right? That's basically alkyl halides. So that's an example of what? Of let me say halogen containing groups that we can have. Now the next thing I'm going to talk about is actually to move on and talk about how to use functional group either as prefix and as suffix, and when to use them as prefix. Then if you want to use them as prefix, what are you going to call them? For example, hydroxyl group, right, is actually used as what? As hydroxyl when it's come as what? As prefix. But at the suffix end, you are going to call it what? All, right? So we can have hydroxyl pentanoic acid. Hydroxyl pentanoic acid simply means there's double bond, two functional group in that compound. One belonging to hydroxyl group and the other one belonging to carboxylic acid. And the reason why we are using carboxylic acid as a suffix is because carboxylic acid actually confirm more functions to that compound, unlike the hydroxyl group, right? So we have hydroxyl and also carboxylic acid. So based on the priority, carboxylic acid was going to come first before hydroxyl functional group. So that's why we are using hydroxyl carboxylic acid. 1 hydroxyl pentanoic acid. 2 hydroxyl pentanoic acid, right? And at the same time, if you are using it as what? As or, which is the suffix n, it basically means it is the functional group present in that compound. Now let's go ahead and see the prefix, how to use them as prefix and also what? Suffix. So now I'm going to talk about the functional group that we have and when you can use them, how the name you're going to call them whenever you're using them as prefix and as suffix. Now the first one I'm going to talk about here is actually the alcohol functional group, right? Alcohol functional group. Now whenever you want to use alcohol, the prefix is going to be hydroxyl, right? Hydroxyl, right? And at the same time, the suffix is going to be O. That's OL. For example, let's say you have a compound and the compound that you have, in that case, you have COOH. Then here you're having hydroxyl group here, right? So one thing that happens is that there is always priority when it comes to organic compound, because alcohol is less reactive compared to carboxylic acid. Carboxylic acid is going to be considered here, right? Because it has more characteristics compared to what? Hydroxyl group. So in this kind of situation, this guy is going to be used as what? As prefix. Don't forget, it is also a functional group, right? Why this guy is going to be used as what? As suffix. So in that case, you're going to have 1, 2, 3. So this is basically 3, since it is coming as what? As prefix. You're going to have 3 hydroxyl, right? 3 hydroxyl. Then since it is 3 carbon atom, you're going to have propanoic acid. That's what you're going to have, right? So now let's now go ahead and have another compound here, and in this case we are having hydroxyl group here, then we're having hydrogen here, hydrogen is here, then the rest is also filled with hydrogen. So in that case, what does it mean? It basically means this is the functional group that we are having here, right? Apart from what? From the single bond, which is actually what? Alkene, we are basically having what? This functional group, and that simply means this guy is not going to be used. This hydroxyl group that I are saying here is not going to be used as what? As prefix, but now it's going to be used as what? As suffix. So we are going to have this whole thing to be what? To be propanol rather. That's what we're going to have, propanol, right? So we're going to use or to represent if it is used as suffix. And then if you have more than 2 functional group and you check the priority, hydroxyl group is kind of lower compared to other functional group. It's going to be used as what? As hydroxyl, right? So that's basically what we have. So now the next one I'm going to, let me simply call this guy out here and talk about another one. So now the next one I'm going to have here, I'm going to write out here. I'm going to have, let me simply say aldehyde, right? I'm going to have aldehyde. So that's the next one I'm going to have, aldehyde. Although aldehyde is kind of reactive compared to what? To ketone, right? It's very, very reactive compared to ketone. So in that case, whenever we have aldehyde, it is going to be used as what? As ozo. And then here is going to be end with what? With al, right? Ozo and al. I'm going to give you example. Now let's say we have a compound like this. Let's say we basically have this compound like this. We have this guy here, and then at the same time, let me simply say we have carboxylic acid here, right? And then we have double bond O here, double bond oxygen here. So in that case, we're going to have hydrogen here, hydrogen is here, hydrogen here, right? So this is basically oxo. So both aldehyde and ketone, they are actually used as oxo. Their prefix actually was oxo. This is basically ketone, not aldehyde. Aldehyde is always on position number 1, carbon number 1. But since I'm having carboxylic acid here, and carboxylic acid is to be considered as far as priority is concerned. Carboxylic acid, you are going to give it what the priority, right? So in that case, you're going to have this guy to the 1, 2, 3 carbon atom abinam. So on position 2, we have oxo. So this is going to be 2 oxo, right? 2 oxo. Then you have 3 carbon atom. You're going to have it to be, let me say, propanoic acid. 2 oxo propanoic acid. That's what you're going to have. But let's say you have a case whereby you have something like this: C double bond O. You are having H here. You have hydrogen here. The rest what is filled with what? With hydrogen. This is also what? Hydrogen, hydrogen, and hydrogen. And as you can see, this is the only functional group that are present here. This is the only functional group. So in that case, you're going to name it as what? You're going to name it as propanal, right? AL is going to end with what? With AL, right? So whenever you're having two functional group and you check the purity, right? Once you check the purity, you find out that this guy here is kind of it is giving what the most purity compared to what this aldehyde that you're saying here. So in that case, you're going to call it 2-oxo-propanoic acid. That's basically when you're going to use them as what? Hydroxy group. But when you're going to use them as suffix AL or OL, that's why they are the main functional group in that compound. Now let's go ahead and bring out the rest. So the next one I'm going to have here is actually going to be ketone, right? That's going to be ketone functional group. So let me basically bring it out. So I'm going to have ketone, right? So ketone, you can use that as what? You can find it as what? As keto, or in some cases ozo as well. Keto or ozo, you can use that. Then here is going to be ONE, own, right? Example, we have ethanone, propanone, right? That's an example. So it's going to be what's own. But one thing I want you guys to understand is that both aldehyde and ketone, they are basically carbonyl compound. They are carbonyl. You understand? They are carbonyl compound, right? So that's basically what we have. Then the next one, let me simply say we have the case of amine, or let me say acyl halide. It's very, very common. It's another functional group, right? And it is made up of carbonyl compound and halide, halogen. You understand? So we can call them alucarbonyl. Alucarbonyl. That's what we're going to call them. Carbonyl. And at the same time, you can see it as oil because it is acyl. Acyl is different from alkyl. You understand? Acyl is different from alkyl. Alkyl simply means the carbon contain oxygen. You understand? This is basically acyl, right? Then I can have chlorine here. This is acyl halide because there is what? There is halide here, right? So in that case, I'm going to have oil. Oil, you're going to have it to be oil halide. It's very, very important. Oil halide, that's what you're going to have it to be. Then that another one I'm going to have, let me simply say we have the case of carboxylic acid, right? Carboxylic acid. That's going to be, let me say, we are having carboxylic acid now. Carboxylic acid. So in that case, as prefix, you call it carboxy. Carboxy, right? That's it is used as what prefix as carboxy, and as suffix you have it as oic acid, right? Then another one that we can have the case of what? Of nitrile, right? It's also a functional group, and whenever you're having as nitrile, you see it as cyano, right? Cyano, it's carbon connected to nitrogen. Then at the end, you're going to have it to be nitrile, right? As suffix, it is nitrile, and as prefix, it is what? Cyano. Then another one that we can have, let me basically say, we have ester rather. We have ester as well. Let me just rub this guy off, alcohol. So let me just put ester here. So we are going to have ester, right? And in this case, whenever you are saying ester, ester is basically alkoxy carbonyl, right? Alkoxy carbonyl. It is used as what? As prefix as alkoxy carbonyl, and then as suffix as OH. OH. You see it as OH as suffix. Then the next one that we can have, let me basically carry all these ones, right? So let's see the next one I can have. You can have the case of what? Of amide. Yes, amide as well, right? And I've explained what amide is, right? So you can have the case of amide, and as prefix you see it as amido, right? You can see it as amido, and then as suffix it is still what? Amide as suffix. Then let's go ahead and talk about the amine as well. Amine, right? So in the case of amine as well, you can see it as amino as prefix, amino, and then amide at the same time as what? Suffix, right? So that's basically what we have. And then, okay, before I forget, we have the case of what? Of ether, right? Ether as well, right? Then we have it as what? As acozy. Don't mix these two guys together, right? They are different, right? Acozy, carbonyl is different from acozy alone, right? They are two different things, you understand? And at the end, you're going to see this guy as what? As ether as well, as suffix. As prefix is what? Is acozy. Then as suffix, you're going to see it as what? As ether. So that's basically the kind of the functional group that I actually have. Then that's just it. Just know that the functional group actually determine the function and the chemical properties of a compound, right? So that's basically what we have. So if you enjoyed this video, don't forget to like, share, and subscribe. It's very, very important. So that's just it about functional group. Thanks for watching.